Hello and welcome to Math Zone African Motives. I'm your host, and today we're tackling a summative assessment on Module 1, Determinants and Cramer's Rule. By the end of this tutorial, you will be able to evaluate determinants, identify matrix elements, calculate minors and cofactors, and solve systems of linear equations using Cramer's Rule for both 2 and 3 variables. So let's get started with our first question, evaluating determinants. Let's begin with the first question. We need to evaluate the following determinants. Let's look at the first one, 1.1. Here, we have a 2 by 2 determinant. The formula for a 2 by 2 determinant is to multiply the elements on the main diagonal and subtract the product of the elements on the other diagonal. So the formula is determinant of a matrix A equals a times D minus B times C. For our determinant, the value of A is 1, B is 2, C is 3, and D is 4. Applying the formula, we multiply 1 by 4, and from that, we subtract the product of 2 and 3. This gives us 1 times 4 minus 2 times 3, which simplifies to 4 minus so. The final answer for the determinant is -2. The memo confirms this is correct. Next, let's look at question 1.2. We need to evaluate the determinant of the matrix with elements 2, 4, 7, and 8. Using the same formula, we multiply the diagonal elements. Here, A is 2, B is 4, C is 7, and D is 8. The calculation is -2 times 8 minus 4 times 7. This becomes -16 minus 28, and -16 minus 28 gives us -44. This answer also matches the memo. Finally, for question 1.3, we evaluate the determinant of the matrix 0, -1, 4, and 3. Applying the formula one last time. A is 0, B is -1, C is 4, and D is 3. The calculation is 0 times 3 minus -1 times 4. This simplifies to 0 minus -4, which is the same as 0 plus 4. The final answer is 4. The memo confirms this is correct. Let's move on to question 2, which deals with identifying elements in a third-order determinant. The question asks us to identify 5 elements from the given determinant. In a matrix or determinant, elements are identified by their position using a double subscript notation. The first subscript, I, indicates the row number, and the second subscript, J, indicates the column number. So, a sub ij represents the element in row I and column J. Remember, rows go across and columns go down. Let's find each of the elements. For 2.1, we need to find a sub 2, 1. This is the element in row 2, column 1. Row 2 is 3, 2, 7, and column 1 is 1, 3, go. The element at their intersection is 3, so a sub 2, 1 is 3. Next, 2.2, a sub 1, 3. This is the element in row 1, column 3. Row 1 is 1, 4, 5, and column 3 is 5, 7, 8. The element is 5, so a sub 1, 3 is 5. For 2.3, a sub 3, 3. This is the element in row 3, column 3. Row 3 is 2, 6, 8, and column 3 is 5, 7, 8. The element is 8, so a sub 3, 3 is 8. Let's continue with 2.4, a sub 3, 1. This is the element in row 3, column 1. Row 3 is 0, 6, 8, and column 1 is 1, 3, 0. The element is 0, so a sub 3, 1 is 0. Finally, 2.5, a sub 1, 1. This is the element in row 1, column 1. Row 1 is 1, 4, 5, and column 1 is 1, 3, 0. The element is 1, so a sub 1, 1 is 1. To recap, here are all the answers. They all align with the provided memo. You can see how important the subscripts are for correctly locating each element. Now let's tackle question 3, which asks us to find minors and cofactors of a third-order determinant. We are given a new 3 by 3 determinant and need to find the minors of 3 and 0 and the cofactors of 6, 3, and 1. Let's first define minors and cofactors. The minor of an element is the determinant of the smaller matrix you get by removing that element's row and column. The cofactor is simply the minor, but with a sign that depends on its position. The formula for the cofactor is C sub ij equals -1 to the power of I plus j times the minor m sub ij. So, a minor is the determinant of a submatrix, and a cofactor is the minor multiplied by -1 raised to the power of the row plus the column. Let's start with the minors. For 3.1, we need to find the minor of the element 3. In our determinant, the element 3 is in row 2, column 2, so we need to find m sub 22. To find the minor, we eliminate the row and column containing 3. The remaining elements form a 2 by 2 determinant. That determinant is 2, 6, 6, 0. Its value is 2 times 0 minus 6 times 6, which is 0 minus 36, giving us 36. So, the minor of 3 is 36. Now, for 3.2, the minor of the element 0. The element 0 is in row 3, column 3. We are looking for m sub 3, 3. The determinant of this submatrix is 2 times 3 minus 9 times 4. This is 6 minus 36, which equals 42. So, the minor of 0 is 42. Now let's calculate the cofactors. For 3.3, we need the cofactor of the element 6. The element 6 is in row 1, column 3. Its cofactor is c sub 1, 3. First, we find its minor m sub 1, 3. Removing row 1 and column 3, the minor is the determinant of 4, 3, so 6, 1. Now we apply the cofactor formula. C sub 1, 3 equals negative 1 to the power of 1 plus 3 times 14. Since 1 plus 3 is 4, an even number, negative 1 to the power of 4 is positive 1. So the cofactor is just the minor, which is 14. Next, for 3.4, the cofactor of 3. As we found earlier, SAR 3 is in row 2, column 2, and its minor m sub 22 is 36. The cofactor is c sub 22, which is negative 1 to the power of 2 plus 2 times 36. Since 2 plus 2 is 4, an even number, the cofactor is again the minor, which is 36. Finally, for 3.5, the cofactor of the element 1. The element 1 is in row 3, column 2. We need to find c sub 32. First, we calculate its minor m sub 32. Eliminating row 3 and column 2, the minor is the determinant of 2, 6, 4, 7. Now for the cofactor. C sub 32 is negative 1 to the power of 3 plus 2 times 10. Since 3 plus 2 is 5, an odd number, negative 1 to the power of 5 is negative 1, so the cofactor is 1 times 10, which is positive 10. A quick look at the memo shows our answers are all correct. This exercise is key to understanding determinant expansion, which we'll use in the next sections. We've reached question 4. Here, we're asked to solve systems of 2 linear equations in 2 variables, x and y, using Cramer's rule. This method is a powerful application of determinants to solve systems of equations. Before we can use the rule, every equation must be in its standard form. ax plus by equals c. The formula for x is d sub x divided by d, and for y, it's d sub y divided by d. Let's define these determinants. D, the main determinant, is formed by the coefficients of x and y. D sub x is found by replacing the x coefficient column in D with the constant terms c sub 1 and c sub 2. Similarly, D sub e is found by replacing the y coefficient column in D with the constants. Let's apply this to question 4.1. The equations are 3x minus 3 equals negative 4y, and 6x equals negative 10y plus 7. First, we rearrange them into standard form. This gives us 3x plus 4y equals 3, and 6x plus 10y equals 7. Now we find our determinants. The main determinant D is formed by the coefficients of x and y, 3, 4, 6, 10. Its value is 3 times 10 minus 4 times 6, which is 30 minus 24, or 6. The determinant D sub x is found by replacing the first column with the constants 3 and 7. The value is 3 times 10 minus 4 times 7, which is 30 minus 28, or 2. The determinant D sub y is found by replacing the second column with 3 and 7. The value is 3 times 7 minus 3 times 6, which is 21 minus 18, or 3. Now we can solve for x and y. X equals d sub x over d, which is 2 over 6, or 1/3. Y equals d sub y over d, which is 3 over 6, or 1/2. The memo confirms this is correct. Let's move to 4.2. The equations are negative 11 equals negative 3e minus 2x, and 4y equals 10 plus 2x. Again, we start by rearranging them into standard form. This gives us 2x plus 3y equals 11, and 2x minus 4y equals negative 10. Let's find the determinants. The main determinant D is 2, 3, 2, and negative 4. Its value is 2 times negative 4 minus 3 times 2, which is negative 8 minus 6, or negative 14. d sub x is 11, 3, negative 10, negative 4. Its value is 11 times negative 4 minus 3 times negative 10, which is negative 44 minus negative 30, or negative 14. d sub e is 2, 11, 2, negative 10. Its value is 2 times negative 10 minus 11 times 2, which is negative 20 minus 22, or negative 42. Now for x and y. X is d sub x over d, which is negative 14 over negative 14, or 1. Y is d sub y over d, which is negative 42 over negative 14, or 3. This also matches the memo. One last problem. 4.3. The equations are 3x minus 5 equals negative 4y and negative 6y plus 7x minus 27 equals 0. In standard form, these are 3x plus 4y equals 5, and 7x minus 6y equals 27. Be careful with the order of x and y in the second equation. Let's find the determinants. D is 3, 4, 7, negative 6. Its value is 3 times negative 6 minus 4 times 7, which is negative 18 minus 28, or negative 46. D sub x is 5, 4, 27, negative 6. Its value is 5 times negative 6 minus 4 times 27, which is negative 30 minus 108, or negative 138. d sub e is 3, 5, 7, 27. Its value is 3 times 27 minus 5 times 7, which is 81 minus 35, or 46. Now the solutions. X is negative 138 over negative 46, which is 3. Y is 46 over negative 46, which is negative 1. This matches the memo as well. So far, we've successfully used Cramer's rule for 2x2 systems. The key steps are to standardize the equations, calculate d sub x, d sub y, and then divide to find x and y. Aquí hay un círculo que se dibuja mientras hablo. Movemos el círculo 2 unidades a la izquierda. Ahora transformamos el círculo en un cuadrado. Ahora mostramos texto en LaTeX. Podemos mostrar texto mezclado con LaTeX como este. Recuerda usar secuencias de escape correctas para símbolos especiales en LaTeX. Puedes usar entornos matemáticos complejos también en LaTeX. Puedes escribir varias líneas usando /par para nuevos renglones. También puedes usar efectos de color en los elementos de LaTeX. Puedes borrar elementos individuales de la pantalla con el gestor de contenido. O puedes borrar todos los contenidos de la pantalla así. Y luego continuar agregando contenido de la siguiente manera. Thank you for watching this Math Zone African Motives tutorial. I hope it has helped you master the concepts of determinants and Cramer's rule. Remember to practice regularly. Subscribe for more tutorials from Math Zone African Motives. See you next time.